Hello everyone, today we're going to learn about working with axes in R. As you say, there's many different ways that you can work with axes. So first of all, we're going to use some data from the plant growth data set. Just let's examine what's in there. So there's a weight and then there's just a group. So control and treatment 1 and treatment 2, so how they were assigned when they were sampled and grouped. So we call that plants. Plant. Just call it plant. Nice and simple. We're going to load that into our memory. Then we're going to use the library ggplot2, and then we're going to use the ggplot command. We set the data equal to our plant data frame. Set the aesthetics. So on the X, it's going to be the grouping variable. So we plant $group, and then on the Y, it's going to be plant weight. Run those 3 lines. That puts it in memory for me. Actually it doesn't, because I've not called it anything yet. Plot. Now that puts it in memory. Okay, it's in memory now. Finally. And then we're going to create a box plot. So let's call it box. Blocks plant. But box plot. Plot plus geom underscore box plot. Okay. Unexpected symbol and box plant. What's the unexpected symbol? Don't get that. Okay, so I'd missed a parentheses off there, that's why it wasn't working. So now if I put the box plant or box plot into the plots window, it gives you that distribution by the group and the weight. So with axes, say I wanted to swap the X and Y around, what I'd just do is with my box plot, I'd then just say coord, so coordinate flip, and then basically height and group will be on the different axes. Yep. So that's how you swap the X and Y around. You just append the coord flip command on the. Okay, say that I've got a continuous, so I've got some counts up the left hand side. These are discrete. Well, these are categorical variables. So in essence, they're going to be grouped into categories. But this is a weight, so it's measured, so it's continuous. It can form any value whatsoever. Again, have a refresher on data types, so whether it's discrete or continuous data. But yeah, that's definitely a continuous axis on the Y. So what if I want to set the limits of that Y axis? Well, I can do this by appending the Y limit command. I'm going to set what I want it to start from and what I want it to end at. So if I use that, now you can see this has become squashed. It starts at 0 and it limits at 10. Another way that you could have done that is by box plant plus scale Y continuous, and then I'd have to use the limits command. So I'd have to make it equal to a vector because it's more than one value, so 0 to 9, say. So that's the same as doing that. So the latter is the same command, but it's a lot more to write. Oh, let me just do that again. So 8. I didn't realise that hadn't worked. So you can see that's a lot more to write than just y limit. So that's a lot easier to pass to your graph. So that's setting a continuous axis, continuous max and min. So you set your limits essentially. If I wanted to reverse these values, so I wanted 0 up to 8, but I wanted it the other way around, I'd then have to reverse the scale on my y-axis. To do this, I'm going to use the data that we created up here with the geometry of the box plot. We called it box plant, confusingly. And then all I need to do here is I just need to append my, because we know it's a box plot, I can then go scale y reverse. See what happens in a second. But yeah, now what's happened is it's gone from up, instead of being upwards, it now aims downwards. So it started at the minimum value there, but it goes up to 6 that way. So the direction's been reversed. You'll be able to know that by the points at the top. They've been moved down to the bottom. Okay, so say I wanted to change the ordering of the grouping, so I want treatment 2 here, treatment 1 there, etc, etc. I can do this by using my whatever I've just created with my geometry, and then I can say on my x-axis scale, we've used the y continuous, now I need to use the x, because it's not the continuous, this would be classed as discrete because it's not a measured value, it's something that is very discrete, so it's a grouping essentially. It's a categorical variable, but it can only take 3 values or 3 groupings. So within the scale x discrete, my limits, I'd need to specify that again to find out how many of those values I've got, so 1 to 3. Then I'd use a vector with a combine function to specify what order I wanted it in. So I'm going to put treatment 1 first, then treatment 2 second, then control last. If I run that line, that should work. I've misspelt again, case sensitivity. Right, so we saw what happened there. That's now reversed. Sorry, that's now ordered my items on my x-axis. So before it was control, treatment 1, treatment 2. Now it's treatment 1, treatment 2 and control. So that's how you basically change the order of your categories if you're using a grouping variable. Okay, now I want to talk about setting the position of these tick marks. So what I do to set the position, set pos of tick marks. What I do here is, again, we're going to use the box plant because that's got all our data and geometry together, so I don't have to keep repeat typing it. If you need to refresh, that's what we did up there. So we added the data and aesthetics layer, and then we added a geometry to it, but that's just a short way of referring to all that. Now we can change the scale of the y-axis. We know it's continuous, and we can specify, if you look up here, there's a breaks command. Again, you can always examine the help by passing help, open quotation, scale y underscore continuous, close quotation, and that will give you the help and all the relevant options for that. But I know that breaks exist within that, so I'm going to specify how my data breaks. So again, we're going to use the vector operator or the combine function. So we know that we've got 3.5 up to 6, 7, should I say. So we're going to specify our first break at 4. Then we're going to say 4.5. Then we're going to say 5. Then we're going to say 7. Say 8. 7.5 and 8. When I run this, the breaks have now been adjusted. So before we had this, and now we've got these tick marks and a massive section above. Most of the time the default options are sufficient, but that's one way you could do it. If I want to completely remove tick marks and labels, I can use a couple of strategies there. So remove tick marks and labels, didn't I say? So here I'm going to use my box plant again. This time I'm going to use the theme option because most of these exist within the theme. So we mentioned earlier in another example that anything to do with the background, etc., the axes, that's covered within the theme settings. So within theme, axis.text on the Y axis. So we basically want to say remove and make that element blank. So just remove it. So if I run that now, as you can see, that's made my values disappear. I could then extend this statement out. So within my theme, so within my theme parentheses, let's just open those up there. Within my theme parentheses, I can put a comma to extend to the next line. I can put axis dot ticks equals element blank. So see what that does. Let's run that line again. It's got rid of the tick marks. So they're the tick marks. Now they've disappeared. Starting to look a little bit nicer. If I wanted to get rid of the groupings as well, I'd just repeat earlier, axis.text on my X is equal to element blank. So now that will just remove everything and just keep it as a box plot. Okay. Okay, say now that we've got our chart here. Let me just remove that because that didn't work for some unknown reason. I'll look that up later on. So apologies for that. If I wanted to then change the appearance of my label, the tick labels. So let's just use the box plot again, just to revert it back to its original state. And then this time what I'm going to do is add the scale X discrete, because that's where my discrete groupings are. So let's just type it, discrete. And then I'm going to add my breaks equal to C. So specify what your breaks are. So the control, treatment 1. They have to match the text that we see in the chart. Treatment 2. Okay. Outside of the vector operator there. So it's always within the C. R helps you with the highlighting of the parentheses, so that one is close by that. Comma. That closes the overall breaks command. But then we're going to add labels. So we're going to change the labels. So for control, we're going to say control for treatment 1. We're going to say treatment 1. for treatment 2, we're going to say treatment 2, surprisingly. So if I run that now, as you can see, my labels have changed. But you need to first stipulate what your breaks are and then what your labels are as well. Say now, and I said I'd cover this from the previous time series. Yeah, when we did the time series analysis, so the line charts, we had a problem with alignment and rotation. So within my theme, so I'm going to call this now adjusted label just plot. That'll put it into memory. So now with my adjusted plot, I'm going to mess around with the theme as well. Again, this will be covered in the more will be covered in the theme section. So axis text on the X, I'm going to use the element because we know it's text. I'm going to specify a rotation angle of 90 degrees. And see what that does. So if I run that, so if I specify 50, that gives me an angle. Obviously I've got a problem here now where my chart's overlapping, so I can also add the horizontal justification equal to 1. And I can also specify the vertical justification and that make that equal to 1 as well. And that just juts down the adjustment on the x-axis so you don't get anything going into your graph. So that's made it look a lot better than the previous one that we had where our labels were starting to impede or impose on the background section. I'm going to add a few more commands here. So under element text, I'm also going to change what font family that text belongs to. So family, let's say Arial, and the face equals italic. See what that does. Italic. Invalid font face italic, use function. Okay, just on a second. It's lowercase. Italic. And Arial. I think that might be right. Gives you an italic face. Which doesn't really matter because it's rotated anyway, so you can't really see what the issue is there. But yeah, that's how you can adjust some of the text on there as well. Okay, now I'm happy with how my chart's starting to look with the adjusted plot. I'm going to also change the text of my X and Y labels. So XLab, I'm going to call that grouping, and then on the Y lab, we're going to call that weight. That just changes the text. I'm going to get rid of the, doesn't seem to like the family, so let's just change the fact. Let me just have a look at the element text. It's causing me an issue. I'll get back. I'm just going to pause it for a second. Okay, that was just because the font family wasn't found in the database. Apologies for that. So yeah, I've added the X label and the Y label now. So height and weight. Say I wanted to remove the grouping label because that's not really adding any value. I can use my just plot, and then I can use the theme command again. I'm going to use the axis title of the X, and then I'm just going to set it again like we've done previously to element blank. That then gets rid of the grouping variable. If I wanted to get rid of the axis title on the Y, I could set that to element blank as well. And that just gets rid of those labels. So that's one way you can add or remove them. I personally think it looks quite good without the labels. If I wanted to change the colour of those labels, the size, I could even change the font family, but I'm not going to touch that at the moment. I can say, let's get rid of that command there on the Y. So, close that off. So, on my X label, I want the element underscore text to show the colour of, let's say red, nice insipid colour there. And let's say we want the size to be equal to 14. Do this again. So yep, that's changed the label. Let's just run those both those lines. Okay, that's odd. I just plot plus the xlab. Oh yeah, okay. Let's call that. Keep adding plots. Let's call it plot 3. So then we use plot 3 and that. So add those two together, and that gives me my grouping label. So it's now red. If I did the same for the, let's do the same for the axis title Y, element text. You can see you can have the same colour, we can have a different colour actually. Let's call it, have a look at the colours again. I always forget these. So R's native colours. Let's say steel blue 4. That sounds nice, doesn't it? So the colour is going to be steel blue 4, and we'll also make the size of that one 14. But this time we're going to also change the angle. So we're going to make that equal to 90. We're going to run those. Okay, element text. Yeah, so that's changed the angle, but I don't like that. We'll do 180, see what that does. Okay, 20. You can play around with those, but as you can see, it's not quite working as intended. So we'll set that back to angle 90, but yeah, just have a tinker with that. So yeah, that's how you can also change the y-axis text as well and change the angle. Generally, that's how you work with the axis though. Please, like I say, if you've got any questions, post them directly to me. But yeah, that's how you can work directly with the axes and configure lots of options. But it's worth, again, reading around the subject because R sometimes can be quite frightening, but once you get used to it, it's a really powerful visualization tool. Okay guys, thanks for watching. Catch me on the next tutorial. Thank you.